Okay, well, let's get going here with the law of cosines. So when you're solving the case of side, 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 and side, angle, side, where you're only given one angle and two different sides, where the angle is in between the two sides you're given, you need to use the law of cosines. And what that side, angle, side looks like, I don't know why I'm on my eraser. Hold on a minute. Would be something like this, where you're given the side, the angle, and the side. So that angle is included between the two sides, different than if the angle was here or the angle was here. Okay, but in the case that it's included, you have to use the law of cosines. And so here is the official law of cosines, and this is the form that you use to find A, B, or C, one of the sides. And then it is also useful in this form right here, and this is a B square. Sorry, I, of course, cut it off there. And this is probably one of the most useful forms here, because a lot of times you need to solve for those other angles. Okay, all right, well, let's get started with our first one here. We're asked to find the triangle, solve the triangle, and that means that we need to find little c, we need to find angle A, and we need to find angle B. And those are the things that we need to find. So I'm going to find C first. So here we're going to use C squared is equal to, because we're looking for C, right? And we know we can use this because we have A, we have B, and we have angle C. See, we have A, B, and angle C. So of course we can just straight up plug and chug this guy. So we'll have 4 plus 9 minus 2 times 2 times 3 cosine of 60 degrees. All right, and so when we put that in our calculator and run it all out, we have C squared is equal to 7. And so that gives us C is equal to the square root of 7. For exact numbers, you're going to be expected to use exact numbers in your calculus courses and stuff, but your homework might ask for a decimal equivalent, so just follow whatever directions your homework is asking you to do. I'm going to, when I can, get an exact answer like this. If this had come out to be 7.3, I probably wouldn't have done the square root of 7.3, but because it was a full round number, then I did the square root of it. Okay, and now what we want to do is we want to find our other angles. Now, the best way to do this is to repeatedly use the law of cosines. So we need to find for angle A, and we need to find for angle B. And so I'm going to write over here real quick. Angle A, we find it by taking the arc cosine of A square minus B square minus C square all over negative 2 times B times C. All I've done is solve this equation right here for C. Okay? Or I guess it was this one right here for A. We don't need to solve this guy for C because we already know what angle C is. So let me write out what we will do for angle B. Just write it out here. So B is equal to the arc cosine, and check it out. It's going to be the B square minus A square minus C square all over negative 2AC. Okay. So let's get over here and find these guys. So our A then is going to equal the arc cosine of, and we'll have A squared, so 4 minus B squared, which is 9, minus C squared, which is 7, because C is the square root of 7, all over negative 2 times B, which is 3, times C, which is the square root of 7. And when we do the math there, we're going to get 40.9 degrees. Okay, and then at this point you might notice that, oh, I could use the law of sines here, but remember when you use the law of sines, you have to consider two cases. If you only have one angle here, you have to consider two cases, what the answer would be in quadrant 1 and what the answer could possibly be in quadrant 2, and then you have to check those. So it's much more efficient for you to just continue to use the law of cosines, even though it might seem like it's a little bit more complicated. Actually, it's just as pretty of a plug and chug, and you don't have to do as many of the equations. It's quite as much solving of equations there, in my opinion. So let's find our angle B, which is what we need to find now. And so that's going to be our arc cosine of, and here it's going to be B squared, which is going to be 9, minus A squared, which is 4, minus C squared, which is 7, all over negative 2 times, and in this case it's going to be A, which is 2, times C, which is the square root of 7. And when we run all that through, we get 79.1 degrees. If you add those together, you're going to get 180. Sometimes you might not get exactly 180. Sometimes you might get something like 79.98 or 79.93, and that usually has to do with some rounding that occurred early in one of your earlier calculations. If you're unsure of something, you'll have to go back in and put that exact calculation in your calculator that is replacing, say, in this case, your C. Say that it was some sort of, well, I'll show you what I mean when we get to a problem that does that. Okay. Let's look at the next one here. All right, so here we're given the angle B, and because we're given the angle B, then we know we're going to be given this from the law of cosines, which is B squared is equal to A squared plus C squared minus 2AC cosine of angle B, and also we're probably going to need to know that A is equal to the arc cosine of A squared minus B squared minus C squared over negative 2BC. And the other one we're going to need is for angle C, which is the arc cosine. And this one we start with the C's, so we say C squared minus A squared minus B squared, all over negative 2AB. It's clearly a pattern, and once you know one, you commit one, then you'll be able to form the pattern for the rest of them. This is why you should not memorize this stuff, but understand the pattern and write them as many times as you can, because they'll commit to memory accidentally, in fact. Okay. So we need to find our B square. So we'll go, our B square is equal to 4 plus 16 minus 2 times 4 cosine of 45 degrees. And that gives us, let's see here, this gives us B squared is equal to, and it's a long number because the cosine of 45 degrees is the square root of 2 over 2, so it isn't a rational number, and so it gives us 8 and I go out 2 decimal points, 69. Now, because we've had to round here, notice that we are going to round here. B is approximately equal to the square root of that, which is 2.95. Okay, so note that we're going to round here. Then you need to note that the sum will be very close to 180 degrees. but not 180 because of that rounding. Okay, so just keep that in mind. And if you're not sure if your answer is right, then what you would have to do is actually plug this entire thing into your calculation over here for the b squared. And same thing there for the b. So, you know, anyway. Okay, so let's continue on here. So we have our b. So let's go ahead and get our angle A. A is equal to the arc cosine of our a squared, which is 4, minus our b squared, which is 8.69, minus our c squared, which is 16, all over negative 2 times our b, which is 2.95, times our c, which is 4. And when we run that through there, we get 28.7 degrees. Now the next one we need to get is our C. And let's see here, our angle C is equal to the arc cosine of our C squared. And our C squared is going to be 16 minus our A squared, which is 4, minus our B squared, which is 8.69, over negative 2 times 2 for our A and our 2.95 for our B. And when we run that through here, we get 106.2 degrees. Now, when you add all this up here, you get 179.9 degrees, which is very, very close to 180. And you have to assume that there was some definite rounding going on here. So these are our solutions. Okay. Now, when you're given all three sides, well, then you just have to crank out the formula 3 times here. So let me just write it down. So our A is going to be given by the arc cosine of our A squared minus our B squared minus our C squared over negative 2BC. Our B is the arc cosine of B squared minus A squared minus C squared over, whoops, I said C squared, but I wrote A squared there. Let me fix that. Negative 2AC, and our C, angle C, is the arc cosine of C squared minus A squared minus B squared, all over negative 2AB. Okay, so I want you to do this one as you do. I'm going to give about 2 minutes for you to crank this guy through, and then I'll be back and work it. This is truly just a plug and chug situation once you learn how to manipulate the problem. Okay, let me get started. Of course, as usual, if you haven't finished yet, please pause now so you can finish. We'll get started with our angle A. Got our cosine of A is 4, so 16 minus 9 minus 36 all over negative 2 times 3 times 6. That's going to give us 36.3. Angle B is the arc cosine of 9 minus 16 minus 36 all over negative 2 times 4 times 6. And that gives us 26.4. And finally, our angle C is the arc cosine of 36 minus 16 minus 9 all over negative 2 times 4 times 3. And that's going to give us 117.3. Cool. Okay, we've got a couple more. Some mixed practice, right? So let's take a look at this guy. Well, the first thing I want you to notice, super important that you notice that you're given two angles and one side. These guys are going to give you this information. We know that sine of 20 over 5 or 5 over the sine of 20 are ratios that we can use. So here I'm just going to use the law of sines. This is a law of sines situation, not sines, sines situation. Okay, so here we go. We're looking for sides here. We can find angle A. Angle A is equal to 180 minus 75 minus 20, which is equal to 85 degrees. So there's that piece. And now we can just use this other information and find the rest of the stuff. Let's see here. We need little a over sine of 85 degrees is equal to 5 over the sine of 20. And when we solve that there, we get a is equal to 5 times the sine of 85 over the sine of 20. So a is approximately equal to 14.6. And then we need b, so we can go b over this. We have b. We need c. So we need c over the sine of 75 is equal to 5 over the sine of 20. Which is going to be b is equal to, I'm sorry, again, c. Goodness gracious sakes alive. Here we go. All right. C is equal to 5 sine of 75 over the sine of 20. And we get that. We get it 14.1. And so we have angle A, side A, and side C. Now I'm going to take a look at this one. we see that we cannot use the law of sines. Law of sines can't be used here because we don't have a side that matches with an angle or an angle that matches with a side. Do you see the difference? Okay, so here we have to use the law of cosines, and in fact we're going to need to find a, so we're going to use our a squared is equal to b squared plus c squared minus 2bc cosine a, and that means that we're going to need to find angle B. So B is equal to the arc cosine of, starting off with the B squared minus a squared minus c squared over negative 2ac. And then we also need angle C. Our cosine of this crap here, c squared minus a squared minus b squared, all over negative 2ab. Okay, let's knock it out here then. So I'm going to find our angle A first. So our a squared is equal to 25 plus 144 minus 2 times 5 times 12 cosines of 60, and that gives us a squared is equal to 109, and so a is equal to the square root of 109. Okay, that's more exact than whatever the decimal approximation is. So if you are given a nice pretty number, then you want to go ahead and put a pretty square root on it. That way you're carrying the whole number and not just a truncated decimal of it. All right, so let's knock it out here. So we have A, so let's find B. So B is equal to arc cosine of our B squared, which is 25, minus our A squared, which is 109, minus our c squared, which is 144, all over negative 2 times the square root of 109 times 12. And when we get all that, we get 24.5. And to find c here, well, say arc cosine of 144 minus 109 minus 25 all over negative 2 times the square root of 109 times 5. And we get 95.5. All right, looks like we got everything there. There's our A, our angle B, and our angle C. Okay, and we have one last one to do. Let's knock it out real quick. We just need to start using the formulas here. So this angle A is going to be the arc cosine of A squared, so 36, minus B squared, 121, minus C squared, 144, all over negative 2 times 11 times 12. That's going to give us our angle A, and that's going to be 29.8 degrees. See what our B is here. Our B is going to be the arc cosine of, starting with B, 121 minus 36 minus 144 over negative 2 times 6 times 12. And that's going to give us 65.8. And finally, our angle C, arc cosine of our C squared, 144 minus our a squared, 36, minus our b squared, 121, all over negative 2 times ba 6, sorry, times b 11, and that's going to give us 84.3. All right. Have a good one.